Hi, hi guys. My name is Sajjan Jasper from CSA department. Currently in my fourth sem. My topic for design and analysis of algorithm for this AAT is on LCD display. Before diving into the topic, I wanna let you know what are the topics that we will be discussing in this video. We will discuss about the introduction, the objectives, the challenges, the outcomes, the advantages, disadvantages, how it is done, system architecture, system design, and etc. Introduction. Let's look into what LCD display is about. The LCD display problem is a classic example in design and analysis of algorithms, DA in particular, that focuses on pattern generation and simulation technologies. The LCD display usually have, few patterns that helps in, getting every single number on the screen. It is a simulation process where every number can be displaced irrespective of the size or the big number it is. It can be displayed on the screen, which can be done using pattern generation and simulation. It is inspired by real world 7 segment displays commonly seen in devices like digital clocks, calculators, and electronic meters. In this problem, each digit 0 to 9 is represented using a combination of horizontal and vertical segmentation. The main objective is to display a given number in LCD style format where the size of the display can be adjusted dynamically. This helps in understanding how to map data into visual structures and stimulate real world systems using algorithms. Like as I've said, we have few patterns which helps each digit is where each digit is 0 to 9 is represented using a combination of horizontal and vertical segments. Segments in the sense lines in particular. So the main objective is to display the given number in LCD style format. LCD display is a pattern-based problem inspired by digital displays. It uses segments to represent numbers, and the goal is to print digits in a scalable LCD format using algorithmic logic. LCD display problem. The LCD display problem is a simulation and pattern printing problem, like as I've said earlier, in design and analysis of algorithms. It is based on how numbers are displayed in real world devices using a 7 segment display system. To solve this problem, we use mapping techniques, or else we use a map in particular, where the digit is mapped to a particular segment and with a nested loops and with a conditional logic inside the loop. This is how we solve the digital LCD display problem. Types of LCD display problem. Basic LCD display. Fixed size that we have is 1. Simple representation of digits. It focuses on understanding the segment mapping, etc. For example, let's say we want to print number 123 in normal LCD form. It can be done because it has a fixed size. This is what basic LCD display is all about. Let's look into what scaled LCD display is about. The size is variable, sometimes it's dynamically done. It controls height and width. It focuses on handling dynamic patterns, like as I said earlier. The dynamic the size is given dynamically, so it is handled dynamically, and patterns are also handled in the same way. More loops and logic need to be put into it. The scaled LCD display. Multiple digital digit display. For example, input is a full number. For example, 45678. It prints all digits side by side. Focuses on alignment, space between digits, so that it falls into a single number, and when the number ends, a space is given into it, and the number is continued afterwards. The other type we have is segment mapping problem. core logic type. Instead of printing, it focuses on which statements are on and off used in optimization, logic building, etc. Properties of LCD display problem. The properties that we have are it is a segment based representation. Digits are formed using a combination of 7 segments A to G. It is a deterministic output. Same input always produces the same LCD pattern. Scalable structure. Display size depends on input parameters S. Structure layer. Output follows a fixed row and column pattern. It is a simple based rendering uses hyphen or line and a space to construct digits. The process that we is involved in is it maps each digit into corresponding active segments, divides the display into rows 2s plus 3, iterates through each row and each digit, printing horizontal and vertical segment based on conditions. It maintains proper spacing according to the number that we in the that is in the input and aligns between digit. Applications of LCD display problem. It is mainly used in digital devices, clocks, calculators, watches, electrical meters, etc. Embedded systems, microcontrollers, hardware systems, etc. User interference, simulation systems, educational tools, helps in teaching pattern generation and algorithm design. Used in game development, used in retro style games for scoreboards and timers and etc. The code for this well-set display problem here is the code is written in C++ because I prefer C++ over Java. I'm comfortable in it. See, line 1 and line 2 are the import methods. Line 1 contains all the inbuilt methods that we can use in the C++. 95% of the inbuilt methods are into this package. Using namespace std is a line which is a shortcut. It's a short form for using uh, cout method. Basically in Java we have system.out.println. So instead, so we do not have any shortcut for that. Basically in what C++ is, we need to use std colon cout. Instead of that, using a namespace std, what it does is we can directly use cout method instead of std hyphen colon colon. So we have this element. We have string int s, string int s and string n. We take the input and we have the string an array. It consists of uh, you know 10 10 values, 10 strings. We have in R. We have a nested for loop and we have an logic if statement into it. Like I said, we have nested loop and a conditional logic inside it, and then we get the output. In the same way, it works. Challenges. It is a complex pattern handling, managing different segment combinations for each. It is very scalable, but also very difficult to maintain it and difficult to scale it. Adjusting output correctly for different sizes. Alignment issues, maintaining proper spacing between digits and etc. Conditional complexity. Multiple conditions for rows and segments can be very challenging. Readability of code. Code can become messy without proper structure and without proper segments or maintainability. The challenges include correctly mapping digits to the segments. If we do not map them correctly to the segments, there is a lot high chance that we get it wrong. Now, handling horizontal and vertical printing separately ensures correct number being displayed on the LCD screen and managing nested loops efficiently, avoiding off by one errors in row calculations 2s plus 3, ensuring consistent formatting across all digits. Tools that we use in this program are C++, Java, Python for implementing the LCD logic, editors, VS Code, programs, mapping techniques, hash map, simulation, etc. Data such as array strings, etc. The implementation we design a segment mapping, write a for loop, and we given a conditional statement inside the for loop. The Uh, for loop goes on and on until the array size and if when the if conditional statement uh, is satisfied, it goes into it and implements the statement. Advantages: it improves logical thinking, enhances coding skills, easy to understand concept, flexible and scalable, low memory usage, good for practice. Disadvantage: complex for beginners because understanding segment mapping can be confusing initially. Lengthy code, high chance of errors, not real world heavy, and formatting issues because managing spacing and alignment is tricky. Conclusion: the LCD display problem is a classic example of simulation and pattern based programming. It demonstrates how real world systems like digital displays can be implemented using algorithms. The problem involves mapping loops and conditional logic to generate structured output. It helps in improving logic thinking and coding skills and problem solving ability. This problem builds a strong foundation in algorithm design and visualization techniques, which are essential for both academic learning and coding intelligence. Thank you.